Good day everyone. In this video I am going to show one other way of proving Pythagoras as illustrated by James A. Garfield, a former United States president who governed America in the year 1881. From the 4th of March 1881 to the 19th of September the same year. Is actually one of the shortest serving presidents of America. But he left a very good legacy where he showed a very unique way of explaining the theorem of Pythagoras, which says a squared plus b squared is equal to c squared. So he came up with a triangle with sides a, b and hypotenuse c. So he drew a triangle like that. Then he drew a copy of the same triangle but being vertical. So he rotated it 90 degrees and then shifted it vertically downwards. So this is the same triangle that appears here. This is B, this is B. This is A, this is A. So C is the same. So in other words, this triangle and that one are congruent triangles. Take note that if this is 90 degrees, then these two must add up to 90 degrees also, so that 90 plus 90 will give us 180 degrees. So in other words, alpha plus beta is equal to 90 degrees. Let's bear that in mind. Those two angles add up to 90 degrees. So if these two add up to 90, it means alpha plus beta, these ones, they also add up to 90. And that leaves us with this one as a right angle. So in other words, this is an isosceles triangle, right angle there. Fine. Let's now look for the area of this triangle. Area of triangle is equal to half base multiplied by height. If I take my base as b, then my height is going to be a. Right? The base and the height must always be perpendicular to each other. In other words, we should have 90 degrees formed between the height and the base. So this is the area of this triangle. But I have got this triangle which is identical to that, congruent to that. So if I multiply this by 2, I now have the area of this one added to that one. Now I am going to add this to the area of this other triangle. If I call this my base, so my area will be half of c times c, half base times height. So this is equal to half of ab times 2 plus half of c squared. This is the same as that, and that will go. So we have AB plus half of C squared. This is the total area of the three triangles. Now, we then look at the entire quadrilateral, which is typically a trapezium, because if this is 90 degrees and this is 90 degrees, it means these two lines are sharing the same perpendicular, and therefore they themselves are parallel. So A and B are parallel, meaning that for the area of a trapezium, the area is half of the sum of two parallel sides, which is A plus B, times the perpendicular distance between them. The distance between A and B is this entire line, which is a composition of A and B. So the height, that is the distance between the parallel lines, is A plus B. So I'm going to have A plus B as this height here, and A plus B as the sum of the parallel sides. So that is the area of a trapezium, half of the sum of parallel lines multiplied by the perpendicular height. This is going to be equal to half of, multiplying by 4, I'm going to have a squared plus 2ab plus b squared which is equal to, if I remove the half, I'm going to have half a squared plus this times that is now ab, 2 will go, plus half of b squared. Okay, but the area of this trapezium should be equal to the sum of the areas of the 3 triangles. So I am going to take this one, which is half a squared plus ab plus half b squared is equal to ab plus half of c squared. But we notice that we've got ab on the left and ab on the right. If I were to take ab that side, it would be ab minus ab. So I remain with half of a squared plus half of b squared is equal to half of c squared. Then we can multiply both sides by 2 so as to clear the denominator. If I multiply here by 2 by 2 by 2, then I have a squared plus b squared is equal to c squared, which is the theorem of Pythagoras as illustrated by Garfield, James Garfield. Thank you very much.